Today we're going to talk about how to decide which method to use when you solve your system of equations, depending on what type of system you're given. In this chart here, you'll see there's three different methods that we've actually used: graphing, substitution, elimination. And there are some keys here to help you decide when to use the different methods. Remember that I told you graphing is probably the least accurate way to do this, just because if you happen to not draw your line perfectly straight through all of the points, or your answer is actually not a whole number, it's really hard to determine the right answer. Could be a decimal, could be that your lines are just off. But the one time that you would consider using this is when both equations are already in slope-intercept form. It's really easy to graph using your M and your B, and then putting them on the graph, finding the points where they intersect. The second method we learned is substitution. Substitution I would use when one equation is solved for a variable, so you have the x or y alone, or both equations are solved for one of the variables. Okay, so the second example here has two x's that are alone. And then elimination, I definitely use when the x and y are on the same side. Sometimes you're going to have to move the variables around like you did in the last lesson to make sure your x's and y's line up, but it's a lot faster to eliminate than to change for substitution. So we are going to go ahead and just look at a few examples and decide which method we're going to use. Okay, so in this first problem here, you'll notice that my y's are alone for both equations. So since I have a y alone here and a y alone here, I'm actually going to take the 6x plus 14 and plug it in. Okay, so this is going to be substitution. So when I plug that in, I have 6x plus 14 equals negative 4x minus 16. And then just remember that since my equations, or my variables, are on different sides of the equation, I'm going to go ahead and cancel one of them out. So I'm going to do a plus 4x on both sides so that these x's cancel to get 10x plus 14 equals negative 16. Then I'm going to solve from there. So subtract 14 from both sides. I get 10x equals negative 30. These cancel. And then divide by 10 on both sides to get x equals negative 3. Okay, like always, we need to take this and plug it back in because we have to have an x and y in our answer. So since this is x equals, we're going to take this and plug it into one of our x's up here. So I'm going to do y equals negative 4 times negative 3 minus 16. And negative 4 times negative 3 is positive 12. And positive 12 minus 16 is negative 4. So my solution should be negative 3, negative 4. I could check that by plugging them into the second equation to see if they actually work. So I'm going to go ahead and do that. So if I plug that into the second equation, y equals, so negative 4 equals 6 times x, which is negative 3, plus 14. Okay, so 6 times negative 3 is negative 18. If I add 18 and 14, I do get negative 4. So I'm in good shape. Those worked out. Let's look at the next problem. Okay, notice in these equations, my x's and y's are lined up perfectly. So if my x's and y's are both on the same side and they're lined up, I need to do elimination. And to do elimination, I need to look at the coefficients and make sure they're opposites. So if I look at the coefficients here from my x's, notice that I have a negative 6 and a negative 2. Those definitely are not opposites. So I'm going to go ahead and look at my y's just to see. And you'll see here for my y's, I have a positive 8 and a negative 8. Those are opposites. So I don't actually have to multiply or change any signs. I can just go ahead and add them together and cancel those right away. So if I cancel my y's out and add my x's, negative 6 plus negative 2 is negative 8, and add my constants, 4 plus negative 6 is positive 8, I can solve for x pretty quickly. So I'm going to divide by negative 8 on both sides. Remember your signs. Pay attention to that negative. And I get negative 1 for an answer. So I'm going to go ahead and plug this in for my x. I'm going to plug it in right here. And I'm going to do negative 6 times negative 1 plus 8y equals 14. And negative 6 times negative 1 is positive 6. So we're going to do minus 6 on both sides. And that cancels. We have 8y equals 8. So my solution here is going to be positive 1. So we have negative 1, positive 1 for an answer. Okay, to check this, we are going to plug those back in to the second equation. So I'm going to do negative 2 times negative 1 minus 8 times positive 1 equals negative 6. So when I multiply those two, I get positive 2. And when I multiply those two, I get negative 8. And 2 minus 8 is negative 6. So we're in good shape. Let's do one more together. We have a system here where both equations are already solved for y's. We could do this the way we did the first one, and we could use substitution if we wanted. I just want to show you one where we're graphing just so you can see. So you could choose either method. Most of you will probably substitute. But I'm going to go ahead and graph these using slope-intercept form since they're both y equals. So I'm going to start with the first equation. I'm going to start with my intercept, which is negative 2. And then I'm going to use my slope, which is negative 3 over 1. So from my negative 2, I'm going to go down 3 and right 1. Okay, I could also go up 3 and back 1 if it doesn't fit. Remember to change both directions, though. Okay, so there's my first line. Let's use this to draw a nice straight one. Okay, so there's my first line. I'm going to go ahead and draw my second line using the same method. So I'm going to start at positive 2 for my intercept. And then since there's nothing out front here, remember your slope is 1. So we're going to go up 1 over 1. And we could keep doing that. We could also go backwards to get our points. Once you have your points, go ahead and use a straight edge and draw a nice straight line. And then find the point where the two lines cross. So in this problem, my two lines are going to cross at the point or intersect at the point negative 1, 1. So if I plug those in, I could check them. This is my final answer. I could do 1 equals negative 3 times negative 1 minus 2, which gives me 3 minus 2, which is 1. Okay, I could check it in the second equation. I could do 1 equals negative 1 plus 2. Well, negative 1 plus 2 is also 1. So it works in both of them. I'm in good shape. I know I graphed them correctly. I want you to go ahead and try the next 4 problems on your own, kind of as guided practice problems, but we're going to talk quickly about which method might be the fastest to use. So example 4 here, you'll notice that your x's are lined up and your y's are lined up. They're both in standard form. So the fastest way to do this is the elimination. Notice, though, that I don't have opposites, so I am going to have to multiply before I can cancel anything out. Problem 5, I have a y by itself. The fastest, easiest way to do this one is going to be using substitution. Since that y is alone, I can take this here and plug it in for the other y and make sure I pay attention to my negative signs when I'm doing my multiplication. For example 6, again, my x's and y's are lined up. I don't have opposites yet, but I could still multiply to use the elimination. So you're going to have to multiply both equations in this problem. And then the last one, again, x's and y's are lined up perfectly. We're close to having opposites in this one. To eliminate, you actually just have to change your signs in one of the equations, and then you can eliminate. Go ahead and do these 4 problems. Once you have your solutions, you can have those checked, and we will give you some practice there. There's also the foldable that we are giving you that you can make like we did last unit, where you can fill in the steps, and there's some more practice problems there if you feel like you need those. If you have any questions, raise your hand. We will help you out. If not, good luck on your homework. Just a heads up, tomorrow you are going to take a quiz over solving systems. So you'll have about 4 or 5 problems again where you just have to choose a method. And then we'll be starting applications. So we'll be doing some word problems. Have a great day.